Hey, welcome. We're surrounded by these massive concrete structures every single day. Buildings, bridges, you name it. They seem so simple, so solid. But hidden inside is this incredible engineering secret that makes it all work. Today, we're cracking that code. We're going to dive into the hidden genius of reinforced concrete. So let's start with a really basic question. Think about a huge concrete bridge with tons of cars and trucks just rumbling over it all day. That bridge is constantly being bent and flexed. So what's stopping it from just snapping in half and collapsing? It seems like it should, right? Well, it all comes down to concrete's kind of split personality. On one hand, it is a superhero when you try to squash it. It has amazing strength under compression. But it has a fatal flaw, a total kryptonite. The moment you try to stretch it, pull it apart, it's incredibly weak. And that weakness to tension, that's the big problem engineers have to solve. And the solution? It's brilliant. It's a perfect partnership. What engineers do is they embed steel bars, we call them rebar, right inside the concrete. Now, steel is fantastic at handling those stretching forces, that tension. So you get this amazing team up. The concrete handles all the squashing, and the steel handles all the stretching. And together, they create this super material, reinforced concrete. Okay, so that brings us to the real puzzle for any structural engineer. You can't just, toss some steel in there and hope for the best. Obviously, too little steel is a problem. But what about too much? Is that even a thing? How do you find that perfect magical balance? And here is where it gets really interesting, a little counterintuitive. The goal isn't just to make the absolute strongest beam possible, a beam that can hold the most weight. No, the real genius of modern engineering is creating a beam that, if it ever has to fail, fails in the safest, most predictable way. It's all about designing for failure. To really get this, let's look at what I like to call the tale of three beams. Think of it like a Goldilocks test for structural safety. We're going to check out three different designs. One with way too much steel, one that seems perfect, and one that's just right. So first up is our too much steel beam. We call this an over-reinforced section. It is absolutely packed with steel. Now, you'd think, wow, that thing must be indestructible. But here's the twist. There's so much steel that the concrete actually becomes the weakest link in the chain. So if you overload this beam, it's the concrete that's going to give out first. And when concrete fails by being crushed, it does not send you a warning text. It's what we call a brittle failure. That means it is sudden, it's explosive, and it happens with absolutely no warning. 1 second the beam is there, the next, it's just gone. It is, without a doubt, the most dangerous way for a structure to fail. Okay, next we have the balanced section. Now, on paper, this sounds like the dream scenario. It's this perfect theoretical knife edge where the amount of steel is so precisely calculated that if it fails, the concrete crushes at the exact same instant the steel starts to stretch. Perfection, right? Well, not so fast. The problem is, in the real world, with real materials, you can never hit that perfect balance with 100% certainty. And since the concrete is failing at the same time as the steel, the failure is still brittle. It's still sudden, totally unpredictable, and gives you no heads up. It's just way too risky to design things this way. And that brings us to our hero, the under-reinforced section. This is the truly brilliant part. Engineers intentionally design the steel to be the weak link here. They use just the right amount of steel so that if the beam ever gets seriously overloaded, the steel will start to stretch and deform long before the concrete is ever in danger of being crushed. And the result of this? It's a beautiful thing called ductile failure. Because that steel is stretching, the beam doesn't just snap. No, it starts to sag, visibly. Big cracks start to appear. Basically, the beam is screaming for help. It's giving you clear, obvious signs that something is seriously wrong. And that gives people precious time to get out and for engineers to figure out a fix. So let's put this all together. Let's look at the verdict here and see why designing for a graceful failure is actually the ultimate engineering win. Okay, check out this table. This is where it all just clicks into place. Look at the over-reinforced and balanced sections. What fails first? Concrete? Or both at the same time? Failure mode? Brittle, sudden. And the most important column, warning sign, a big, fat no. But then you look at under-reinforced. The steel fails first. The failure is ductile, it's gradual. And the warning sign? Yes. That yes right there, that's everything. That's the difference between safety and a disaster. It feels a little weird, doesn't it, that we're intentionally choosing a design that is, in a way, weaker, just to make it safer? Why is a design that actually allows for failure the best choice we can make? The answer comes down to one hugely important word in engineering. And that magic word is ductility. It's the ability of a material, like our steel rebar, to stretch and bend and deform before it actually breaks. This incredible property is what lets that under-reinforced beam sag and crack and give us that warning. Ductility isn't a weakness at all. It's a built-in, life-saving alarm system. And you have to understand, this whole concept, it isn't just a clever trick or a good idea. It is a fundamental, non-negotiable rule of all modern structural engineering. So here's the bottom line. Building codes all over the world, like India's IS 456, for example, they actually forbid engineers from designing over-reinforced beams. The rules literally force them to design for this ductile, warning-first type of failure. So remember, a beam that's bending and cracking under an insane load isn't a sign of a bad design. It's a sign of a very, very good one doing exactly what it's supposed to do. So the next time you look at a bridge or a skyscraper, remember that hidden genius locked inside the concrete. It's not just about being strong. It's about a clever, life-saving partnership, designed with the incredible wisdom that the very best structures don't just stand strong, they tell us when it's time to get out of the way.
Watch the basics of steel structure and unbelievable strength of hollow section. Thanks for watching. Do like, subscribe and share it with your friends and colleagues. Stay tuned with Structures by Steps.